Hello and welcome everyone. In this tutorials we'll be going through on how to deploy a Dockerized Python web application on AWS. We'll be using Terraform for the automation and Nginx for the load balancing. The repo that I'll be going through is a complete end-to-end deployment solution, meaning it will create a custom VPC, subnet, security group, EC2 instances and few other things. This can further be customized as per one's need. We are going to use an AMI that is already ECS-optimised AMI 2 for creating the EC2 for our Docker workloads as well as for our Nginx. So let's get started with the tutorials. So this is going to be the flow of the tutorials. I'll start with the sample application that I have created for this demo. It's quite a basic Python application, nothing fancy, and a Docker file that we can use to Dockerize the above Python application. Then I'll go over the Terraform code in a bit more details. I'll go over the overall architecture that we have used. Once again, this will be quite basic. I'll go through the Terraform file layout, and I'll also go over the individual resources that we have used. So the application, the demo Python web application, it runs on Python 3 and it's created using Flask modules, which is nothing but a lightweight web application framework. It's quite easy to get started with, and it's also using WTForms, which is basically a reusable forms. It can be customized and templatized as per the needs. We will be using validators in WTForms as well as pattern matching in HTML. Both are done to validate the inputs that we will be providing. And we will be Dockerizing the application, which makes it compatible and maintainable, meaning it can be run independent of the platforms. Let's look at the files and the folder structure for the application now. So this is the application folder, and you can see that we have a Docker file in the main folder, and then there is a source folder. So everything that is required by the Docker file to create the image is put in the source folder. Source folder contains requirements.txt file, which basically has all the requirements for the Python code to run. Then we have the Python code itself, and then we have two subfolders called template and static. The template subfolder will have the web HTML that the Python code calls, and the static subfolder has all the static files that are required by the HTML to run. Now just let us look at the requirements file there. So the two main models that we are calling in the Python code, Flask and WTForms, are mentioned in the requirements. So as a prerequisite, we'll use this file to install the modules before we run the code. This is the code itself. So we are using Flask and WTForms. You can see that the Flask is initiated using by the name app, and then we are using class reusable forms for the WTForms, and that class is being called in the function. The function is basically, all it is doing is depending on the option that we choose in the HTML form, we are just displaying the name or we are not displaying the name. So that is the two things that we are doing. So if you look at the web HTML, there's nothing fancy here. So we are having basically two placeholders. One is for the drop down and one which prints the username that we enter. And these are the static files that are used by the web HTML to render or just to provide styling to the UI components and the page layouts that we have. Let's look at the deployment now. So we will be using Terraform for automating our deployment. We are going to use ECS-optimised AMI 2 AMI, so they already have Docker and Docker dependencies pre-installed in them, and we are going to use Nginx for our load balancing need. This is how the architecture looks like. So we're just going to make a HTTP call to the Nginx at port 80, which is going to forward the request to either of our Docker nodes, which will be running on port 8080. You can see that we will be creating a custom VPC and a custom subnet. We also will be creating two security groups, one for the Nginx and one for the two Docker nodes that we have. So the Nginx security group will allow the traffic from all the IPs on port 80, and the security group for the Docker workload will be allowing traffic only from the VPC CIDR, and that too only on the port 8080. Let's look at the Terraform files and folder structure now. So this is the Terraform folder. So I've basically tried to break down different resources logically so that it's easier for us to manage. As you can see, we have different Terraform files for the network, for the nodes, for the security group, and for the IO, which is nothing but input variables and the output that we want the Terraform to display. So the main file contains the provider, which in this case is AWS. We also have a Terraform backend, which is nothing but S3 in this case. So we'll use this backend to store the state files. We are also generating a key pair. This is just in case if we have to log into the nodes, if we have to SSH to the nodes to troubleshoot some issues. Our network file has VPC, custom VPC being deployed. Then we have subnet, and we have internet gateway and route table. Our security group Terraform file has two security groups as mentioned earlier. So there is one for the Nginx and there's one for the Docker workload. So the Nginx security group, we have port 80 opened up to all the IPs, whereas the instance security group, which is used by the Docker workload, has port 8080 opened only to the VPC CIDR. We also have SSH ports opened up for both the security groups. This is just so that if we need to do any initial troubleshooting, this can be disabled later. Our IO file has all the input variables that we need, which can be customized or changed as per our requirement, and it also has the output which we want the Terraform to display at the end of the process. We also have two shell scripts which we are going to use as the user data for the nodes that we are going to create. So this is the work node 1 and work node 2. So these two work nodes will be using user data in shell script 1, which is all it is doing is just enabling Docker and running this command, and this is the Nginx instance that we are spinning up, which is going to use the shell script 2 for as a user data, and we're also going to take the IPs from work node 1, work node 2 and add it to the host so that it can resolve the host names. Okay, so the resources required for this tutorial, there are a couple of them. So all the files, including the Python application and the Terraform deployment files, have been uploaded to the Git. There is also a short video demo on how to use the repo. Links for both of them have been given in the description below. Okay, so that's it for the tutorials. Please let me know if you have any doubts regarding this. Thanks for watching.